I am going to try to connect this little stepper motor. You can see how tiny it is compared to this NodeMCU and this drive 8825. But I need to get wires connected to these little pins. You can see how tiny they are. So what I'm going to do is I'm going to take this really thin FR4. You can see how thin it is. It's about 0.8 millimeters thick, and I'm going to mill it out so that it sort of makes a connector. Because I've got to connect these 4 wires to it, I'll kind of cut these off and solder it to it. So I'll show you how to make the board in Eagle, and then how to use ChiliPeppr's Eagle board import to mill it out. So I'm in Eagle, and I created a quick schematic. I'm generally mimicking the layout of the circuit board. And here's the board I laid out. The one thing I had to do was really make sure that these pins were the correct dimensions away from each other. So we'll save that out, and then I've got that, then I will drag this board in. So of course ChiliPeppr's got an Eagle board import widget that it's got some pretty nice features to it. The important part is I only have a top layer, the milling path. I could probably go a little bit wider. Let's say I did 0.4, and then when you tab out of that, it's supposed to re-render, but here I'll hit render. And they kind of overlap, which I don't mind because as it drills, it'll kind of create isolation traces anyway. But maybe for the sake of cleanliness, let's see if 3.5 gives us right at what we want. No, we'll go a little bit smaller because you can still see there's a little bit of overlap there. So we'll just do 0.3, render that, and then I don't really need to I don't need to do any advanced inflating. We'll show the actual end mill path, which takes a little bit longer to render, but not bad on a tiny thing like this. So you'll see that my end mill is, I'm saying it's 0.35 millimeters wide. Now, the end mill I'm going to use has sort of a V-tip to it, but that's still a pretty good estimate. And then that should do that. And then for the Gcode, it's a 1 ounce copper, right? So I could do exactly 0.035. That's a little light in terms of detail. I could go 0.07. Let's just go 0.06. I'll go really narrow on it. The problem if you go not too deep is you may have to go back and mill again, but if you go overly deep, you are beating through your end mill, because the FR4 underneath is a very tough material. So you really want to try to limit that. Feed rate for milling traces, I leave it 80. That's the default. It's pretty slow, but it's pretty safe. And then that feed rate for plunging, which is really the drill plunge, that's pretty safe. Actually, that's the plunge down into the trace. 10,000 RPM is fine. I think the default's 12,000. The clearance for ZX moves, you could go higher than that, but it just doesn't matter too much because I'm going to probe the board. And then I do want to drill holes, so I want to mark the holes for drilling. What that does is the end mill that you're using to do the traces just puts like a little dot in the middle, and it makes sure that when you then come back with a drill bit, it doesn't bounce around. Depth for drilling holes is the board depth. Maximum hole diameter shouldn't matter. Feed rate of 100. So the diameter of tool cutting for dimension, I'll use like a chip breaker at the end. I'll show you that bit, or that end mill. So depth of cutting out dimensions of board. My board's actually 0.8. I'm going to go a little bit deeper than that just to go into the board underneath, the waste board. And the step down, we'll make it just be 1 pass. So that should be exactly 1 pass. And then 100 millimeter. It's still pretty slow. You can cut and paste this Gcode if you want. But what I'll do is, now that I'm happy, I will send the Gcode to workspace. Now, I'm finding that doesn't always seem to appear, but the moment you turn this off, it's there. So I'm looking at my I'm looking at that trace that I just sort of laid out. using that wider end mill, or sorry, using that thinner end mill, and I decided I don't want to beat on it because it's a $28 end mill that does the 0.35 millimeter trace, and I just don't need that detail, so I'm going to use one of my cheaper end mills. This is 0.6 millimeter, and let me zoom in here, but I think what I like better about this is the part I'm worried about is the width between these pins, and this will give me, this is the only detail part, right? The trace is this way, it's nothing, there's plenty of room. Okay, so we're back in ChiliPeppr, and we had the milling path being inflated by 0.3, but what you really want to do is visualize how your end mill is going to cut. So my end mill is 0.6 that I'd rather use because it's a cheaper one, and I can definitely get away with it on this job. The key is I'm worried about this little overlap, and what I really want to do is almost make, when the end mill comes around this way, it follows almost the same line as this, because I want these pieces of copper as big as they can get for the most soldering. So let's now go up and play with our inflation to see. I want like almost a perfect overlap, so let's go 4. And you know, over here I get a little bit far, but I don't care about these little, you know, this end mill path swiping into this. Even let's go 0.45 and just see what that looks like. Okay, so that's pretty reasonable overlap. And this way that I think I'm pretty good. I mean, I'm almost gonna get the inner blue line to intersect, because all of this non-blue area will end up being copper. Remember, the light cyan blue is just the isolation trace. You do want your traces kind of wide, since you're not going to put solder mask on this. I have found that you can end up with just the flux sort of flowing into the channel and causing a connection. So the further it is, the better. That's pretty nice. I'm going to go with that. Let's send the Gcode to workspace. Turn off Eagle board import. And there you go. That looks about correct. And that overlap there looks correct. All right. Board set up and ready to go. But I decided this is the sort of the chip breaker I'm going to use to cut the FR4. That's a 1/8 inch, so 3.175 millimeter. So I got to change my Gcode. All right, we're back here in ChiliPeppr. I'm going to go back to the Eagle board import, flip it back on. I'll hit render, and I need to go to the, first of all, I want to turn off, yeah, I turned it off already. I'm going to turn off mark holes for drilling, because I decided I'm just going to drill the holes with the 0.6 millimeter end mill. So even when it asks for a tool change, I'll just continue to use the end mill and not change tools. Here we go. Diameter of tool cutting. So 3.175. And when I render that, that won't matter. Depth of cutting up board. I know it's 0.8, so that one's fine. 0.85. And then feed rate for cutting dimensions. You know, 100's probably pretty safe, but let's just go 80 since I'm doing one pass. It's probably unnecessary. The other thing I'm thinking is when I'm cutting, well, I'll show you. I'm going to send the Gcode to the workspace. But, okay, it's wider, so that's good. It starts here, so it's going to take away the board over there, which means the board on the left and the right are going to, it's going to come out the moment the end mill sort of reaches right around here. So that's probably fine. I don't need this board to be that precise. Okay, now let's auto level. Okay, for auto leveling, I can just take my touch plate and just rest it on the copper, because that's obviously going to be conductive. And then I need to attach this, and we should be safe to get going with the auto level. And then you want to jog it to the correct location to get started, meaning you want to get close to your absolute zero. So you're going to want your X and your Y in the 0 position. Auto level only does the Z position. All right, we're gonna now try the auto level now that we've got our XY pretty dialed in. Okay, so keep in mind the auto level starts automatically way out there, but our board is at this 0 over here, so we've got to adjust that. We want to start at 0. Even then, I'm going to cheat and start at 0.5, 0.5, okay? Because I actually don't want to probe right at that corner because it's dangerous. Oh, let's set this machine to 0. I forgot to do that. I'm glad I just did that. It's too hard to probe that corner because there's only a tiny bit of copper that end mill will touch. And we're only going to really probe 4 points here, it looks like, because it's unnecessary otherwise. So what I'm going to do is I'm going to do steps every 2 millimeters. So let's end at, let's say 10 and see what that does. Yep, that looks clean. Okay, let's do the clearance height is 1.5. Start probing at 0.5 millimeter. Probe feed rate. I'm going to go even slower. I know it seems odd, but maybe not. And then I already tested the probe, so I know it's working. So let's go ahead and give it a try. But, you know, I always sort of have my finger on feed hold if this screws up. You'll notice what it's doing is it's showing you the warpage of each point. Obviously you can tell it's not that far off, but the first point that it does in the lower left corner becomes the 0 reference. And then everything else is sort of, is it higher or lower from it? Such a cool feature. I love this. Okay, we are done probing. Looks awesome. And then what you do is you send your auto level Gcode to the workspace. And just like that, we can now turn off auto level. Okay, now you want to take off your touch probe and get ready for milling. Okay, so I'm a little bit worried that I doubly modified my original Gcode with this auto level. So here's how you fix that, just to really make sure. You don't want to auto level twice because you'll actually adjust your Z's too much. I was thinking more about how the auto level showed that it was going lower than the amount I was milling with anyway. So here's what you do. You go back to the Eagle board import, you re-render, and then you resend your Gcode to workspace. Let's just see if that works. There it is. Just running slow, probably because I'm video recording. So I turn that off, and then I want to review here and just make sure there's no Z mods on any line, and you can see there are none. So nothing's been modified, because there's only X and Y values spit out by the Gcode widget. So that looks really clean. And now we'll go back to the auto level. What it does is it still saves our previous data. So you can go up here and say, see how it auto-saved it? So I'll load that, and then we'll send our auto level Gcode to the workspace. Now we will turn off the probe data matrix and go back. We'll turn off auto level. And we shall now see and hear a bunch of AL newsies. Okay, we are ready to run here. So we're going to, I switched back to G54. so that I'm back in my normal G54 coordinates, and we're going to get going. So turn on the spindle. And hit start. So you can see that the copper did not get milled off there. It didn't get milled off here either. Now that doesn't matter a ton, although it sort of does because this looks connected. And that doesn't matter either because that's isolated, but I'm going to just run it again. Okay, so we are on a tool change pause, which I'm going to just stop the job. Remember, line 488 is where we're at, but we're going to rerun it. What we'll do, though, is I'm going to go to machine 0. And notice I'm right at the Z0, and I'm going to go down, not 0.1 of a millimeter. I'll go down by 0.01 on the Z. Not much, right? But we were milling at 0.06. I even recommended to mill at 0.07. Let's see what happens there and rerun it. So what we do is now we set that as our new machine 0. Okay. And then I'm going to turn on the spindle and hit play again. Okay, let's now go ahead and mill out the dimensions. So I think 445 probably was correct. What we do know is that this move, if you hold down the shift key, that's line 590. Oh, that's on the way up. We want the one on the way down here. Let's do this one. That's line 493. So you can just say go to. So we know that that's pretty much, yeah, the dimensions start right at 492. So we will, the Z is starting here at 1. So we'll go ahead and send Gcode to move to this position. And then we should be moving, yeah, we'll set this as our new start position. That should be correct. Zoom back out, turn the spindle on. And go ahead and hit play. Okay. We can hit feed hold here. We don't need to go the rest of the way. We'll wipe the rest of the job. And we are done. Okay, fits on like a charm. You can see it's right on there. And a beautiful little breakout board. Look at that. Motor's working. So the circuit board, nice and tiny. But you can see that the 4 pins to the motor are soldered in there. The way this is set up is I've got a drive 8825 running, and I've got a NodeMCU that I programmed through ChiliPeppr in the NodeMCU workspace. It's running Lua, and it's just sending step and direction signals to the motor, and then I'm powering it with the lowest voltage you can possibly power this thing with, which is 8.3 volts.